Today we're starting chapter 2. We're going to start with quadratics, okay? And what we're going to have is we're going to have a set of skills that we need to be able to master. And this is the absolute minimum requirement of these skills. And then we have our success criteria abstract. Now you all have a copy of this. You're able to go back and refer to it at any time. So what we're looking at in chapter 2 is we're going to be looking at solving quadratic equations, completing the square, looking at quadratics as functions, quadratic graphs, and the discriminant. So the discriminant is something completely new, okay? But everything else is an extension or is GCSE level. So, obviously, why do we use quadratics? We use them for a lot of things, but projectile motion is probably the best one, looking at distance and displacement, you know, forecasting what's going to happen, what a curve's going to look like. And we're going to have a bit more of a discussion about that once we get through the chapter. So, I would like you all, as a starter, to quickly solve by factorising and solve by using the quadratic formula. Off you go. Make sure it is equal to 0. So we're going to minus 6. Two numbers that multiply to give me minus 6, but add to give me 5. Negative 3, no. Plus 6, negative 1. Okay, and that equals 0. But when we're solving quadratics, okay, this isn't just the answer, we've just factorised it. What number would make this bracket 0, okay? And it's when x is minus 6. I know some of us like to say we change the sign, but we really need to understand what's going on, because this is going to help us when we look at the discriminant and start sketching. So, because if you think I've got a bracket multiplied by a bracket equals 0. So either this bracket needs to be 0 for this to equal 0, or this bracket needs to be 0. That's why we change the sign, and it's really important we understand why. So x equals negative 6, x equals 1. Okay? Using the quadratic formula, we should be happy to use the quadratic formula. And we have our A, B, C. So our A equals 1, B equals 5, C equals minus 6. We should know the quadratic formula off by heart. Minus B, plus or minus the square root of B squared minus 4AC all over 2A. Okay, it's really important we memorise this because we are going to need this for the discriminant. We plug in, we substitute in our values. So wherever there's an A, we're going to put a 1. Wherever there's a B, we're going to put a 5. It's really important that whenever we substitute values in, we are writing brackets. And you'll see what I mean in a second. So then, when you substitute it in, you're going to have minus bracket B. It's so important we use brackets. Plus or minus the square root of 5 squared minus 4 lots of A, which is 1, C, which is minus 6, all over 2 bracket 1. We're going to get answers of minus 6 or 1. Alternatively, use your calculator. Go to the function that says equation and type in your A, B, and C, and you will get those answers, okay? So, if we are solving without factorising, a lot of people look at this, x minus 1 squared equals 5, and immediately people want to expand that bracket. There is no need to expand that bracket, okay? Because how do you get rid of a square root? A square? You square root it. So we're going to square root both sides. So we're going to get x minus 1 equals plus or minus the square root of 5. Okay? Then I'm left with x minus 1, so I'm going to add 1 to both sides. So I'm going to get x equals 1 plus or minus root 5. So I'm going to have two values for x. X equals 1 plus root 5, or x equals 1 minus root 5. Now, we like to keep things as numbers, okay, as exact numbers. We wouldn't turn these into decimals. We would keep them exact. So we have quadratics in disguise. So here, I'm going to rewrite this. We have x minus 6 to the power of a half plus 8 equals 0. Now, if we multiplied x to the power of a half times x to the power of a half, I'm going to get x. So this is in fact x to the power of a half squared. So this is going to be x to the power of a half squared, because that's going to give us x to the power of 1, minus 6x to the power of a half plus 8 equals 0. Okay, so all I've done is rewritten x in terms of halves, x to the power of a half. Now, what we can see here is x to the power of half, something squared, minus 6 lots of something plus 8. It is a quadratic in disguise, because quadratics always go something squared plus something x plus a number. So what we're going to do is we're going to let y equal x to the power of a half. So wherever there's an x to the power of a half, I'm going to substitute in y. So now I'm going to have y squared minus 6y plus 8 equals 0. Now this is a form that we know. Once we've undisguised it, we've substituted, we all know how to solve this now. The hardest part of this question is finding what we need to substitute. This will come with practice. Now we have a quadratic, we should be able to solve it. Minus 4, y equals minus 2 equals 0. So now we get y equals 4 and y equals 2 as our answers. But we haven't finished yet. Because we used substitution, we have to go back. We know we said that y equals x to the half, okay? So this is saying x to the power of a half equals 4, or x to the power of a half equals 2. We don't want x to the power of a half, we want x. So to get x, we have to square both sides, because that would give us x to the power of 1. So if I square both sides, I'm going to get x equals 4 squared, which is in fact 16, and x equals 2 squared, which is in fact 4. So the answers for the question is 16 and 4. Okay? Now this comes in, why we're getting x on its own, this comes in from indice laws from previous chapter 1. Okay? And just to give a bit more clarification, x to the half squared, we know, is x to the power of 1. And whatever we do to one side of the equation, we have to do to the other side. What I'd like you to do now is to test your understanding, okay? You have 4 questions to do. Depending on where you are, you might choose to go for the green, you might choose to go for yellow, you might choose to go for red. I'm completely happy wherever you start. You decide. How confident did you feel? If you felt really confident, go straight for red. If you didn't feel really confident, maybe try some of the green. If you felt a bit, okay, go for orange. Give it a go, please. You know, I said in the previous example, it's easier for you to square root. This only works if you have an integer on the right-hand side, because you're going to get a number. So, for example, for this one, I'd have 2x plus 1 equals plus or minus root 5. For the first one, I would expand out the bracket. And then start my working from there. Okay? For the third one, I'd square both sides, so I get x plus 3 equals x minus 3 squared, and I'd expand the bracket on the right-hand side. And then for the last one, I'd use substitution. Let y equal x to the power of a half. Okay, so for the first one, I'm going to have x squared plus 6x plus 9 equals x plus 5. If I minus x and minus 5 from both sides, I'm going to get x squared plus 5x plus 4 equals 0. Factorise, I'm going to get x plus 4, x plus 1 equals 0. So x equals negative 4 or x equals negative 1. For question 2, I'm going to minus 1 from both sides to get minus 1 plus or minus root 5. Then I'm going to divide both sides by 2 to get minus 1 plus or minus root 5 all over 2. For question 3, I'm going to get x plus 3 equals x minus 3 squared, which is x minus 3 times x minus 3. So I'm going to get x squared minus 6x plus 9. I'm going to minus x and 3 from both sides. So x squared minus 7x plus 6. Factorise. X minus 6, x minus 1 equals 0. X equals 6 or x equals 1. And then for question 4, we substitute in. Okay, we have a quadratic that we're used to. We solve the quadratic. We get our two values for y. We need to make sure we substitute back in to find our values for x. So, completing the square summary. We should all be very happy expanding x plus 9. We should have x squared plus 18x plus 81. Okay, and x minus 5, we should have x squared minus 10x and plus 25. Everybody should be happy with that, okay? And the relationship between the bold numbers is they are square numbers. Okay, when you think you're plus 9 and you're minus 5, we square them. Sorry, they're not square numbers, but we square them to get this 81 and this 25. That's what the relationship is. Now, when we're completing the square, if you have x squared plus 12x, we could say, essentially, this is the same as writing x plus, now with the number 12, we halve it. So we're going to get 6 squared minus 36. Now the reason I've done, sorry, I'm going to put minus 6 squared. The reason I've done that is because if I did x plus 6 squared, I would get an extra 36, and I don't want that, so I minus 36, okay? So, those of you who do not know how to complete the square, again, you need to know this, and I'm just going to run through it really quickly. It's always x plus or minus, depending on the question, something squared, minus something squared. Everyone happy with that? Okay? This is the rule. So, this number 7 just goes at the end here. So you can just write that there straight away. Okay? Whatever this number is, you divide it by 2. And then you put it here. Okay? Very simple. Then, whatever this number is that you've divided by 2 with the sign goes here. So then we're going to have minus 3 plus 7. That is how we complete the square. So we're going to have x minus 3 squared minus 9 plus 7. We're going to have x minus 3 squared minus 2. We should have remembered that from GCSE, okay? If not, please work on that at home. So then, those of you who are confident, can you go straight to this question here? Those of you who are not, who have seen that before, I'm going to show you how to do this different one, okay? If you're confident, go straight down to the bottom question. Now, the method I just showed you, where it was bracket, bracket, x plus squared minus bracket, bracket squared, is always the same. But this only works if you have a number 1 in front of the x squared. So the coefficient of x squared is 1. That's what I mean. The coefficient means the number in front of the x squared is 1. In this case, the number is 2. So we cannot start with that formula, okay? We have to have, it has to be 1 for this method up here to work. So what we do is we divide everything by 2. So I'm going to take 2 out and put a square bracket, okay? I'm happy for you to all watch this one first if you want to. 2x squared divided by 2 is just x squared. 12x divided by 2 is 6x. 7 divided by 2 is 3.5, but we love to keep things as fractions, so we're going to write 7 over 2. Okay, and then I'm going to finish with my square bracket. Everybody happy? Now, this 2 in the square bracket, we're going to leave exactly how it is. Just leave it, okay? We're not going to worry about it for now. Because what we have here is x squared plus 6x plus 7 over 2. The coefficient of x is now 1. We only have 1x squared. So I can use this formula that I've just shown you. Okay? So I start off with bracket x plus, remember I half this one. What is half of 6? 3. Bracket squared minus bracket, whatever this is 3. I put here. Squared plus 7 over 2, because that was what was on the 8. So now once we've done that, we can leave our 2 again on the outside, but what we're going to do is we're going to simplify what's inside the square bracket. So we're going to have x plus 3 squared minus 9 plus 7 over 2 is 18 over 2 plus 7 over 2 minus 11 over 2. Okay, so I've simplified it. So then what I'm going to do is I'm going to multiply 2 by the bracket, which is going to give me 2 bracket x plus 3 squared. And then I'm going to multiply 2 by minus 11 over 2, which is just minus 11. So that is the actual answer. Now I'm going to do the exact same for the second example. This time, when I look at the example, instead of, the only way I can use this formula, x plus or minus squared minus bracket bracket squared, the only way I can use that formula is if x is just x squared on its own. Okay, the coefficient of x squared is 1. Here the coefficient is minus 3. So what do you think I'm going to take out the bracket? 3. Minus 3. Okay, and then I'm going to have square brackets, and I'm going to divide everything by minus 3. 5 divided by minus 3 is minus 5 over 3. Minus 3x squared divided by minus 3 is plus x squared. 6x divided by minus 3, minus 2x. Okay, again, a lot of this I'm doing in my head. Please feel free to use a calculator if you need to. I'm going to rewrite this. Minus 3 bracket, and I'm going to write it in the form x squared minus 2x minus 5 over 3 and close bracket. Okay? Now I have it in the form I need it. So I'm going to leave my minus 3 on the outside. The coefficient of x squared is 1. So now I'm going to put it in completed square form. Bracket x half of b minus 1 squared minus 1 squared minus 5 over 3. Okay? Now what I'm going to have is minus 3, open bracket, x minus 1 squared, minus 1 squared is 1, minus 1, minus 5 over 3 becomes minus 8 over 3. Then I'm going to multiply everything by minus 3, so I'm going to get minus 3 bracket x minus 1 squared plus 8. Now again, a lot of the multiplication I'm doing in my head, and we should be at the stage where we're comfortable doing this in our head. I've given you 10 minutes, which is a lot more than really I would normally give. So, step 1, 3x squared minus 18x plus 4. The coefficient in front of the x squared, okay, is a 3. Okay, so first of all, I need to divide everything by 3. So I'm going to get 3 bracket x squared minus 18 divided by 3 is minus 6x. 4 divided by 3 is plus 4 over 3. Now, inside my square bracket, I have x squared minus 6x plus 4 over 3. That now means I can complete the square as normal. So I'm going to get 3 bracket x minus 3 squared minus 3 squared plus 4 over 3. Okay, which I'm then going to simplify inside the square bracket. X minus 3 squared minus 9, 27, minus 23 over 3. Now I'm going to multiply everything by 3. So I'm going to get 3 bracket x minus 3 squared minus 23. And that is the answer. For the second part of the question, the coefficient in front of the x squared is negative 5. So I need to take negative 5 out and divide everything by negative 5. 20x divided by negative 5 is negative 4x. Negative 5x squared divided by negative 5 is x squared. 3 divided by negative 5 is negative 3 over 5. Now I'm going to rearrange this in the form x squared at the beginning. I'm going to get negative 5 square bracket x squared minus 4x minus 3 over 5. Now it is in the form that I can complete the square. So I'm going to get negative 5, open bracket, x minus 2 squared minus 2 squared minus 3 over 5. Okay, minus 2. Then I'm going to get minus 5 bracket x minus 2 squared minus 4 times 5 minus 4 minus 20. Is it minus 23 over 5? Oh, sorry. No. What? Wait there. Minus 4 is minus 20 over 5. I get the same again. Oh. Okay. Then I'm going to multiply everything by minus 5. So I'm going to get minus 5x minus 2 squared plus 23. I'm going to rewrite that. So I've got 23 minus 5 lots of x minus 2 squared. So, okay, we're going to do the exact same again. Now, if we look at this question, we'll notice the first question is the same question as the first question before. So, step 1 is complete the square, which we've already done on the previous slide. We're going to get 3 bracket x minus 3 squared minus 23. We've already done that on the previous slide. Everybody should be happy with that. Now it says solve the equation. This is where it's a bit different. Solve the equation, and here's the equation. And it equals 0. We have to solve this. Now, the reason why we have to solve this equation by completing the square is because if you try it now, try this into your calculator, your A equals 3, your B equals minus 18, and your C equals 4. Try that into your calculator using the solving the equation button, and it will come up as error. Okay, it turns out this one we can factorise. Normally, we complete the square when we cannot factorise, okay? How we solve this, though, I'm so sorry about that, is once we complete the square, we have it in the form 3 lots of x minus 3 squared minus 23 equals 0. All we're going to do now is classic rearranging. I'm going to add 23 to both sides. So I'm going to have 3 lots of x minus 3 squared equals 23. Then I'm going to divide both sides by 3. So x minus 3 squared equals 23 over 3. Then to get rid of the squared, I'm going to square root. So I'm going to get x minus 3 equals plus or minus the square root of 23 over 3. To get rid of the minus 3, I'm going to add 3 to both sides. So I'm going to get x equals 3 plus or minus the square root of 23 over 3. And that is the answer. Yeah, one sec. So this is the final answer, okay? And that's how we've done it by solving. What I would like you to do now is, I know we've only got a few minutes left of the lesson, but everyone should be completing the Dr. framework. If you have struggled with this lesson, you have extra homework to do. You have to do question 3, A, C, and D. Extra homework, A, C, and D, as well as Dr. Frost, as well as the formal homework for chapter 1, and I will set something else, okay? And this is all due in on Sunday. What was the question, Faisal?
They wanted us to sketch an equation, like a graph of an equation they gave us.
Which is?
X squared plus 3x minus 4.
X squared plus 3x minus 4. Okay, and how many marks did I give? 4 marks. Let's see who's got 4 marks then. Step 1, it's a sketch, okay? You know it's a quadratic, so you don't even have to worry about anything. When you're sketching, you know if we factorise, we'll get the roots. So I'm going to get x plus 4, x minus 1. So I know this is going to be minus 4 and this is going to be 1. Now that I know that, I know 1 is roughly here, minus 4 is roughly here. But I don't actually put those dots in, but I know I'm going to have more on the left-hand side, if that makes sense, than the right. The reason why I don't put those dots in is because I do this. Voila. Perfect. This is 1. This is minus 4. Okay? This one is also minus 4. It's the y-intercept. We get that here. Okay, so far you've got 1 mark for this. 1 mark for the minus, I'll do this in a different colour. 1 mark for minus 4 and 1. Okay? Then the next mark you're going to get is you need to complete the square to find the minimum point. So we're going to have x plus 3 over 2 squared minus 3 over 2 squared is 9 over 4 minus 4, 16, so minus 25 over 4. So we're going to get x plus 3 over 2 squared minus 25 over 4. Now the minimum point is whatever's inside the brackets, essentially we flip it, but I don't like saying it like that. When does x equal 0? When does that bracket equal 0? And that's when x is minus 3 over 2. And then the y is just the integer that's left over. So then this point here is your minimum point. Okay? And this is minus 3 over 2 and minus 25 over 4. Okay, so there's 3 marks so far. Not yet, Najib, hold fire. Okay, this is 1 mark here. Are you ready for the last mark? Please make sure you label your x and your y axes. Okay, so everybody always forgets that, but that's an easy 1 mark. Okay, so today we're moving on to the last part of our chapter, and we're going to get through this in the next 20 minutes. We're going to go fast paced. It is very simple. Functions, very easy. You have an input, you have an output. So this function, what have we done? We've multiplied it by 2. Because if we input x and we get out 2x, it's a multiply by 2. Now a function is the same as a lot of equations, okay? So when we write in equation form, these are functions. X squared is a function. You put in one value, you get another value. Now, something you need to write down. The domain of a function is the set of possible inputs. So the domain of a function is normally your x values, okay? So write that down. Domain is possible inputs, which is normally you input. So for here, we'd input x's, wouldn't we? So domain is your x values. And your range is the possible output. Now, when we're looking at a graph, your range is normally your y coordinate. And again, I'm going to explain that in a bit more detail in a minute. Okay? So, everyone should be happy. Now, a function can only exist if it's one-to-one. Okay, that means I put one number in and another number comes out. Okay? But with a function, I can have, for example, the same output. So, for example, if I put in -4, I could get 16, because -4 squared is 16. If I put in 4, I also get 16. I can get the same output, okay? Right then. So, this is back to GCSE stuff. So we should be fairly confident with this. We have a function, x squared minus 3x, and gx equals x plus 5. X belongs to the real numbers. So this is our domain. This is telling us that x can be any number, okay? So we know x is any number on the graph. So if we had a graph, sometimes it tells us that x is between 3 and 2, but this, it says it belongs to real numbers. So it's any number along here, any number across the x-axis. We should be happy with that. So, number 1, find f is -4. So I'm going to substitute in -4. So if we think about a function, this is f of x. And everywhere there's an x, we're going to substitute in a -4. When we use substitution, we need to make sure we put brackets. -4 squared minus 3 lots of -4. Those of you who struggle with mental arithmetic in your head, the reason why we do brackets is because when you put it into your calculator will do BIDMAS. Okay, so we need to do brackets first. So, 16 plus 12. So f of -4 is 28. And again, if you can't do that in your head, please use a calculator, but use your brackets. Find the roots of f of x. When we're finding the roots, that means we are solving it. We put it equal to 0 and we solve it. If it says find the roots, equal to 0 and solve. So we're going to get x squared minus 3x equals 0. In this case, we can factorise. X brackets, x minus 3 equals 0. Now again, how we find the roots. When does this equal 0? Okay? Now, either x has to equal 0 because 0 times bracket is 0, or the bracket has to equal 0 because 0 times this number will be 0. So we're going to have two options. X equals 0, or the bracket, which is x minus 3 equals 0. If x minus 3 equals 0, that means that x has to equal 3. So, these are the roots. X equals 0 and x equals 3. Those are the roots of the equation. And the roots mean where it passes on the x-axis. Here we go. That is where the roots are. Then says, find the roots of f of x, g of x. So again, when we're finding roots, you put it equal to 0 and solve it. So x plus 5 equals 0. So x must equal minus 5. Nice and simple. It's only got one root. Great. Sorry everyone. I've done C and D as B, and we've lost B. I'll do B now. Okay, so this is C, this is D, this is B. Okay, so nice and easy for the next one. Right. Then we have B. Find the values of x for which f of x equals g of x. Okay, f of x equals g of x. This should be nice and simple for you. F of x is x squared minus 3x. So instead of writing f of x, you're going to write x squared minus 3x equals, and your g of x is x plus 5. So instead of g of x, you're going to write x plus 5. We're going to rearrange. I'm going to put everything on the left-hand side. X squared minus 3x minus x minus 4x minus 5 equals 0. I'm going to solve this. Okay, so we're going to get x minus 5 and x plus 1 equals 0. Again, when are the brackets 0? When x equals 5 or x equals negative 1. Okay, we should be fairly happy with that from GCSEs. The next example is when it says find the minimum or the maximum. And as we've just seen by sketching the graph, to find the minimum or the maximum, what do we need to do? Complete the square. We could do that, and we're going to look into that, but at the minute it's just about completing the square. So very quickly, x minus 3 squared minus 3 squared plus 2. We're going to get x minus 3 squared minus 9 plus 2 is minus 7. This equals 0. Okay, so when we're finding our minimum value, what makes the bracket 0? 3. And then our y-coordinate is minus 7. When we're trying to solve for x, that's when we put it into e equal to 0. But we can find our minimum point by putting it in this way. And we're going to come to why it works in a moment. So we're going to complete the square. So we're going to get x plus 2 squared minus 4 plus 5. Minus 4 plus 9 is plus 5. So we're going to get minus 2 and 5. And we want to find x for which this minimum value... Oh, right, sorry. One's asking for the y-coordinate, one's asking for the x. I've just written the whole coordinate, but really, the minimum value of the function... Sorry, I didn't read the question. The minimum value of the function is 5, and the minimum value for x is minus 2. Okay, but I've just written it in coordinate form. I'm happy for us to do coordinates. Right, all we're doing is x squared plus 4x plus 9. We cannot find the minimum point without putting it in completed the square form. This is completely equivalent, okay, to x plus 2 squared plus 5. And that's because if I expand this out, x plus 2 plus 5, x plus times x, x squared, 2 times 2, 4, 2 times x, 2x, 2 times x, 2x, plus 5. X squared plus 4x plus 9. This equals the left-hand side. We are not changing what this is. This is the exact same function. We're just writing it a different way. That's all we're doing. For example, the number 4. We can write that as 2 squared. We can write that as 5 minus 1. As long as we do not change the value, we can rewrite any mathematics any way we want. Okay? So we can always double check if we're right or not by using that. Okay then, next up. So x minus 5 squared. So minus 25 plus 21 minus 4. Okay, so our minimum value is minus 4. And this occurs when x equals 5. So I'm going to get 5 minus 4 is my coordinate for the minimum. Now, when we have a negative x squared, we don't have a minimum, we have a maximum, okay? So, 10 minus x squared, how am I going to solve that and find the minimum or the maximum? okay? Realistically, this is incompleted the square form already because we have no coefficient of x. So if we were to complete the square on this, we'd end up with a 0, half 0 is 0. So this is already incompleted the square form essentially, because we can't do anything about it. So our coordinates for this is 0, 10. Okay? Because there's no coefficient in front of the x, it's just how it is. So then for the last one, we have a minus x squared. When I'm completing the square with a minus, I need to take a minus out of everything. So I'm going to have x squared minus 6x minus 8. Now I can complete the square on that. So I'm going to get x minus 3 squared. Minus 9 minus 8 is minus 17. Okay? Then I put the minus back in. So I'm going to get minus x minus 3 squared minus 17 again. So my maximum is plus 17 because I've multiplied it out. So my maximum value is 17 when x is 3. So my coordinate is 3 and 17. Please make sure that we're happy with those. Okay, so if you are happy, you go straight to question 3. If you got all of them right, straight to question 3. Okay, if you're not happy, well, no, I'm not going to use the word not happy. If you're less happy, no. If you're satisfied, can you go to question 1 or 2? You can pick, okay? And if you have no idea what's going on, I will be walking around the aisles shortly. Okay, so for the first one, we're finding the minimum value. And if we're finding the minimum or the maximum, we've got to complete the square. So I'm going to get 2 lots of x squared plus 6x minus 5 over 2, which is 2 lots of x plus 3 squared minus 9, which is 18 over 2 minus 23 over 2. And then I'm going to get x plus 3, 2 lots of x plus 3 squared minus 23. So my minimum value is going to be at minus 3 and minus 23, okay? For the second one, we're finding the roots of the equation. So we're going to have to factorise. So 2x, x plus 1, this equals 0, okay? So when does this bracket equal 0? Well, so 2x plus 1 equals 0 when x equals negative a half. And this bracket, x plus 1 equals 0 when x equals negative 1. So these are the roots. Then for the last one, we need to do substitution. So if we let y equal x squared, we're going to get y squared minus y minus 6 equals 0. We're going to get y minus 3 and y plus 2 equals 0. Y equals positive 3 and y equals negative 2. Now remember that we use the substitution. So now x squared equals 3 and x squared equals negative 2. For this one, x is going to equal plus or minus the square root of 3. For this one, we reject. The reason why we reject it is because we cannot square root a negative number. Okay, this is not allowed, so you would write reject. So this graph, it would only cross the x-axis once. Okay, it would look like this. So can you see it only crosses it once? But if we worked it out, it'd have one minimum and one maximum point. Okay? I have already shown you how to sketch a graph, and we all seemed fairly confident. We need to remember, okay, these are the roots. How do you find the roots? And that's by solving the equation. Okay, and we solve the equation by making it equal to 0. Okay, this point here is the y-intercept. Okay, this is normally just the number on its own, isn't it? At the end. Okay, this is like the plus c. This is when x equals 0, you'll find the y-intercept. You could always substitute it in. This is going to be the minimum or the maximum point. And how do we get that? Completing the square. Okay? Then, this one is just making sure the shape is correct, okay? If you have a positive x squared, you're going to have a u. If you have a negative x squared, you're going to have a n. Okay? So, okay, this is nice and sketched. This is the one we did earlier. Okay, and we can see we've got our 4 marks. Okay? Here we have a 4x minus 2x squared minus 3, and you can see we've got the sketch here. Okay? Got minus 3, 1 and minus 1, and the reason why is when we try and do the roots, there are no roots. Comes up with error. We can't factorize it, and if we put this into our calculator, there is an error. So could you try that for me in your calculator? Your 4x, so I'm going to rewrite it as minus 2x squared plus 4x minus 3. So your a equals minus 2, your b equals 4, and c equals minus 3. Yeah, so this should either come up with an error, or we're going to get the square root of something and an I, which is an imaginary number which you're not going to learn about unless you do further mathematics or take up a degree in mathematics. So don't worry about that. But it doesn't cross the axis. So if that happens, you're not going to have anywhere that crosses along here. Okay? So what I would like you to do now is I want you to make sure you can sketch these graphs. There's 4 of them to sketch. It shouldn't take you long to sketch a graph, so I am expecting you to do them all. Okay, step 1, draw your axes and always write x and y. Step 2, now, I don't need to solve this in any way because x squared graph always looks like this. Okay, and it crosses at 0, 0. Now, if you think about a function, right, do you remember when we were transforming graphs? And if we plus 4, all it does is goes up 4 because it's not inside the bracket. Is it inside or outside the bracket, Sarah? Outside the bracket. So we're just going up 4. So actually, it's going to look like this. And this point here is 0, 4. And that's it. Done. Right then, so B. We have x squared minus 7x plus 10. We can factorise that to get x minus 5, x minus 2. So x equals 5, x equals 2. So those are our roots. That's where it crosses the x-axis. We can complete the square. X minus 3, 7 over 2 squared. 49 over 4. Plus, is it 9 over 4? Yeah. So plus 9 over 4. Now, just to reiterate, I've done that in my head. Okay? It's minus. I've completely done that in my head. Okay? And double checked that it's correct. If you do not know how to do this, please look at the previous ones and completing the square. It's just, I've missed a step out. I've just tried to do it as fast as I can. No, you don't need to do it in your head. I'm just doing it in my head. And then the y-intercept equals 10. So, sorry, just got a smoothie of the marks running down my face. Whew. Right, back again. So now what we're going to do is we have all the points that we need. The coordinates of this one is going to be 7 over 2 and minus 9 over 4. So here we go. We have our sketch. X and Y. If you don't have that, just mark your homework all as wrong right now because that's not acceptable. Hazel? Oh, perfect. Then we know it's going to be 2 and 5, so we know it's going to be about here. This here is 2, 0, 5, 0. We're going to have 0, 10, and then our minimum is going to be 7 over 2 and minus 9 over 4. Okay, so that is exactly 4 marks, and that is where we should be, as a class, we should be getting comfortable with that. Okay, that is our minimum expectation, and that's GCSE and a little extension, so well done if you got that right. Okay, the next one in our sketch, can someone tell me the factorised form, please? Or what are my roots? 3 and negative a half. Okay, so if those are my roots, I can always put it back in. So x is minus 3 and 2x plus 1. Okay? I should be confident that if we've got the roots, we can put them back in. This is how we can cheat factorising. Okay, you know when it factorises, if you use your calculator to find your roots, you can just reverse it and put it back into the equation. Okay? So then, completed form square, please. Okay, is that right? Anyone? 49 over 8. Okay, so well done. Yeah. And then, yeah, you've got to times the 49 over 16 by the 2, because you're bringing that 2 back, yeah? You multiply everything by 2. So then, again, we have 3 and minus a half. 3. Ooh. No, this doesn't make sense. Oh, yeah, that then it does make sense. Okay. There we go. So this is our 3, 0. This here is going to be 0, 3. This point is going to be minus a half and 0. Don't forget your x and your y. And then this point is going to be, so this should be positive 49 over 8 then. Yeah. So this is going to be 5 over 4 and 49 over 8. Okay? Perfect. Now the last one. When we try and factorise, what happens? Error. Oh. It gives you imaginary numbers, yeah? So that means it's an error. Okay. So there's got no roots, that's fine. My y-intercept is 11, and when I complete the square, what do I get? X plus 2 squared, minus 4 plus 11 is plus 7. So we're going to have minus 2 and 7 as our coordinates. So when we draw this now, because it has no roots, okay, we can't factorise it. It's going to look like minus 2, 7 is roughly here, okay? So now it's going to look like this. So it's crossing here at 11, and this minimum point is minus 2, 7. It doesn't cross the x-axis, so it means it has no roots, okay? If it doesn't cross the x-axis, it doesn't have any roots. So that's how the graph's going to look. I know some of us didn't get that quite right. But at least now we know how to do it. Thank you. So these are the graphs. Find the equation. Now, this is what I just showed you a little bit of then. Okay, if the roots are 3 and 5, you know that x equals 3 and x equals 5. You could just put them back in. X minus 3, x minus 5. Okay, and then if you expand that, you're going to get x squared minus 8x plus 15, which makes sense because your y-intercept's plus 15. Nice and easy. It's just reversing. Okay, part B, you get x is minus 2 and minus 5, so you're going to get x plus 2, x minus 5. Okay, but if we did 2 times minus 5, we're going to notice that we're going to not get a positive 10. And if you look at the graph, it's a negative. So actually, it's x plus 2, and then it's 5 minus x. Okay? Or it could be 2 minus x, either way. one of them is going to be a minus. Or you could put a minus on the outside. Okay, and what you're going to end up is with minus x squared minus 7x plus 10. Okay? Did you get minus 3? So what do we have? Oh, it's, yeah, you're right, sorry. Yeah, okay. Is that in the answer too, yeah? Right, the next one, it's 3 and minus 3. So you're going to have x minus 3, x plus 3, which is the difference of two squares. So we're going to get x squared. But that doesn't give us minus 18, does it? No. So, why does that not give us minus 18? Because this is actually an enlargement. So we need to put a 2 on the outside. So we're going to have 2x squared minus 18. Okay? Then for the last one, I'm going to get x minus 4, x plus 1. Now, then that should give me minus 4, but so we're going to have a quarter of that to get the y-intercept, because it's currently, it crosses at minus 1. If I multiply this out, I'm going to get minus 4, so I need to do a quarter. So I'm going to get x squared over 4 minus 3x over 4 minus a quarter, minus 1. Okay? Perfect. Right then, so we should all be fairly confident with graphs. If not, we'll do some more work on that. Some of you may have done the extension. Did anyone do it? No, I'm not going to go through it then. If you want to do it, you can. Okay then, so moving on. How many distinct real roots? Now this is new. This is new content now, everyone. Everything else we've done so far is what we should know, and maybe just a bit some of the harder questions, if that makes sense, okay? But this is completely new. So how many distinct real solutions do each of the following have? Can you please either solve them by factorising or put each one into your calculator to see what the solutions are? Now, when we're looking for solutions, and it says real solutions, okay? So imaginary numbers are not real numbers. So we're looking for our solutions. I want to know what's going on. Okay, so you can put each one into your calculator. You know that your A is always the number in front of the x squared, your C is the number in front of the x, and B is the one in front of the x, and your C is the other one. Now, I don't like saying the number in front of, okay, so can we make sure that we understand the term coefficient, okay, is the number in front of. If there's no, if you just have 1x squared, the coefficient is 1, okay? So I want us to get really used to understanding. We also take the sign with the coefficient. Do not forget about the sign. That's probably one of the biggest mistakes. Okay? So make sure that you are completely happy with this. Right then. So you should have put these into the calculators. For the first one, what does x equal, please? 6. Is that it? Yeah. Okay. For the second one? No real solutions. And for the last one? 1 plus or minus the square root of 2. Okay. So that means that either you've got x equals 1 plus root 2 or x equals 1 minus root 2. Now, you've had to sit and work that all out. Okay, but actually we've got a formula that we can use to determine how many real roots an equation has. Okay, so as I said, the discriminant is known as b squared minus 4ac. Okay, and that's called the discriminant. You need to learn that. So here we go. What we have is something called the discriminant. Okay, the discriminant. Now, on the quadratic formula, okay, we have minus b plus or minus the square root of b squared minus 4ac over 2a. This is the quadratic formula, okay? Now, the discriminant is this part here. Oh, sorry, not including the square root. It's this part here. Okay, this is the discriminant, right? Now there are a few rules, okay? There's only 3 options, okay? We can have 2 real roots. Oh, I've put roots, okay? We can have 1 root, as we've seen, but there's another name for this. It's called equal roots. Okay, and the reason why it's called equal roots, I'll explain in a minute. Or we can have no real roots. Okay, and that's when we get an imaginary number or we get an error. Now, this happens, believe it or not, on 3 different occasions. So the discriminant is b squared minus 4ac. Is everyone happy that the discriminant is b squared minus 4ac? Now, we get an imaginary number if we try and square root a negative number. So for any equation, if b squared minus 4ac is less than 0, we get no real roots. Okay? If b squared minus 4ac equals 0, because if this equals 0 here, we've got the square root of 0, we don't have the plus or minus bit. We're just going to get minus b over 2a. So if it equals 0, we're only going to get 1 root, or equal roots, okay? And then, lastly, if b squared minus 4ac is greater than 0, we're going to have 2 real roots. So what this actually means, I'm talking about all these roots and everything going on. What this means is when I have my graph, if I have 2 real roots, it's going to cross the x-axis at 2 points, okay? If I have 1 root or equal root, it's going to cross the x-axis at 1 point, okay? And if I have no equal roots, what's going to happen is it's not going to cross the axes at all. And all I'm talking about is the x-axis here. It's really simple. So again, here we've got just a few more pictures to show you that as long as you understand exactly what each one means and what it represents on a graph. So, the reason why we say equal roots and not 1 root, you can actually read through this at a later date, but just very quickly, if I was to factorise this one, I'm going to get x minus 6 equals 0. So I actually have 2 lots of x minus 6, don't I? So that, in theory, you know, that's the kind of short of it. It's equal roots because 6 and 6, they're equal to each other. But really, it's just 1 root, okay? But have a look a bit more into that for those who want to challenge yourselves. So then, what we're going to do very quickly is we're going to do some quick fire questions, okay? The discriminant is b squared minus 4ac. So for the first one, to calculate it, and I'm just going to make sure everyone's happy. Remember your A, B, C. Okay, so for the first one, I'm going to have b squared, which is, now I'm always, and this is very important, whenever I substitute, I use brackets. 3 squared minus 4 bracket 1 bracket 4. Okay? Now, some of you might be able to do the discriminant in your head for each one, but I just want to make sure that we are completely happy with how this looks. So you know where every point has come from. Okay, and then if we do this, we're going to get 9 minus 16. Okay, 9 minus 16 is 9 minus 16? Thank you. Minus 7. Okay, this is less than 0. If it's less than 0, we have no roots because it's less than 0. Okay, you've got 1, 2, 3, 4, 5 to do. Off you go. Okay then, so b squared minus 4ac. So I'm going to do this in my head. So I'm going to get 16 minus 4. That's positive, so I'm going to have 2 roots. Okay? I don't actually, because these are just quick questions, I don't actually need to work out the entire number. It's good that you know how to, and if you are. So we are going to do 12 is greater than 0. Okay? Which is 2 roots. Everyone happy? Okay. B squared, so 16 minus 16, I'm going to get equals 0. That means it has 1 root, or equal roots. Now I'm going to get 36 plus, this is going to be greater than 0, isn't it? Yeah. 2 roots. Okay, and that's because I'm doing 6 squared, which is 30, negative 6 squared, which minus 4 lots of a, which is 2, minus 3. I know that I've got a positive plus a positive. Okay, I don't even have to work that out. Okay, for the next one, again, I'm going to have 1 squared minus 4 lots of minus 3, lots of minus 4. That's going to give me a negative number, isn't it? It's less than 0, so it's got no roots. Then our b is 0. So we're going to 0 squared minus 4 lots of 1 minus 1 lots of 1, which is positive. So 2 roots. Okay, because if you think, don't forget everybody, your A is pink. Okay. Your B is green. Well, we don't have a B in this case, so it's 0. And your C is the coefficient. Make sure you understand exactly what's, not the coefficient, the integer. Okay, make sure you understand exactly what's going on. So here we have an exam style question. This is 6 marks. It's such a lovely question for 6 marks, okay? Really lovely. So I'm going to do this question. You don't have to write it because you're going to have your own questions to do in a minute. I just want everyone focusing and listening. Again, you can take pictures of, pictures and whatever of this can be done later. This is all saved as a video. So, are we ready? Here we go. The equation x squared plus 2px plus 3p plus 4 equals 0, where p is a positive constant, has equal roots. In the question, if it ever states something has equal roots, the first thing that you should come to mind is that b squared minus 4ac equals 0. That is the first thing that should come to mind. Equal roots, b squared minus 4ac equals 0. I want you to live and breathe that. Okay? That's what I want. So, again, we're going to use the colour coding. Your A is the coefficient in front of the x squared, which in this case is 1. So, you need to write this down. I would always suggest. So your A is 1. Perfect. Your B is the coefficient in front of the x, which in this case is positive 2p. This is, 2p. Or to be or not to be. I don't know. Right, then the coefficient, the C is our constant. Okay, it's the one that doesn't have an x near it. It's just a number. And in this case, it's this. Okay, so everyone should be happy. And again, use some highlighters if you're getting confused. What is going on? 3p plus 4. 2p. Okay. So, Then it says, find the value of p. Well, it's really easy to find p because you know that b squared minus 4ac equals 0. So we're going to have b squared. Now, I keep saying to you, make sure we are right in brackets. This is b squared minus 4ac. So our b is 2p, our a is 1, and our c is 3p plus 4. And we've got to find p. So now, 2p squared is 4p squared, minus 4 lots of 3p plus 4, because I multiplied it by 1, okay? Which is going to give me 4p squared minus, and remember this equals 0, because we've got equal roots, doesn't it? Minus 12p minus 16 equals 0. Okay? Believe it or not, what have we got? A quadratic. I can't even believe it, can you? Right? So, what we're going to do is we're going to solve it. P squared minus 3. So I'm going to get p minus 4p plus 3 equals 0. Not 3, sorry. 1 equals 0. I was thinking it has to give me 3 because I divided everything by 4. Again, I'm just doing this in my head. You can do this on a calculator. So our p equals 4 or p equals minus 1. Nice and easy, 4 marks right there. 4 marks for doing that. And I expect you to show all of these steps. Okay? Okay, so that was a good question that Najib asked. What would happen if a was, for example, minus 2? Here it's lucky it's 1, so I've just got minus 4 lots of 1, which is why I've got minus 4 here. If it was minus 2, I'd get minus 4 lots of minus 2, which is plus 8, and then I'd have 8 lots of the brackets, okay? So I've got p equals 4, p equals minus 1. So for this value of p, solve the equation x squared plus 2px plus 3p plus 4 equals 0. We have 2 values for p, so this is just, imagine, it's like quadratic simultaneous equations. Okay, we now have 2 values of p. I've got to put those 2 values of p into the original equation to get 2 outputs. So if we let p equal 4, then our equation is going to be x squared plus 2 lots of 4x, because instead of p, we've said it's 4, plus 3 lots of p plus 4 equals 0. So that's going to give me x squared plus 8x, 12 plus 16 equals 0. I'm going to factorise this, solve this. I'm going to get x plus 4 squared, so x equals minus 4. Okay? Now, again, I have done that in my head. You need to get to that stage by the end of December. You will, but use your calculator. Now, if p equals minus 1, we're going to have x squared plus 2 lots of minus 1 x plus 3 lots of minus 1 plus 4. So that's actually going to give me x squared minus 2x. 3 times minus 1 is minus 3 plus 4, which is minus 1, which equals 0. But I think that also gives us x minus 1. No, I don't think we can solve this. Yeah, this is plus. Oh, this is a plus 1. Ah, there we go. So x minus 1, x minus 1. So this is x minus 1 squared equals 0. So x equals 1. So we have 2 solutions. X equals minus 4 and x equals 1. So what I would like you to do now is you have 2 questions to do. Test your understanding. Everyone start with the green and then move on to the yellow. Okay then. I'm just going to quickly go through these and then after that we've finished chapter 1. Okay, we've got a few questions to do. Great, we've finished chapter 2 then. Even better. Right, it has equal roots. What's the first thing we should be writing down? That b squared minus 4ac equals 0. Okay, now our b is whatever is in front of the x, so the coefficient of x. So we're going to have 5k squared minus 4 lots of a, which is 1, lots of c, which is 10k plus 5, equals 0. So I'm going to get 25k squared minus 40k minus 20 equals 0. If I factorise that, what do I get? X equals 2 and x equals minus 2 over 5, okay? But it's not x, is it? It's k. Nice and simple. That's the first one done. And again, that's worth 4 marks. 4 marks for that. Really, really nice and easy. Right, the next one's slightly different, and this is why it's covered in orange, because some of you may or may not know the answer to this. Find the range of values of k for which x squared plus 6x plus k equals 0 has 2 distinct solutions. If it has 2 solutions, b squared minus 4ac is greater than 0. We've just written down those rules. Okay. My b is in fact 6 squared minus 4 lots of a, which is 1, lots of c, which in this case is k. That is greater than 0. Okay? So I'm going to get 36 minus 4k is greater than 0. Now, when you solve this, we can do this a few different ways. Okay? I want k on its own. Right? So we could move the 36 onto the other side. So we're going to get minus 4k is greater than minus 36. If we divide by minus 4, though, what do we have to do? Change the sign. Well done. So then, if I divide both sides by minus 4, I get k is less than 9. So what this is saying then is for this to have 2 distinct solutions, k has to be less than 9. Okay? So let's actually give this just a bit of a go. Okay? So this is just for, being curious mathematicians as we are. Let's try k equals 10. X squared plus 6x plus 10. Okay? What happens if k equals 10? If you put that into your calculator, it should give you an imaginary number. Error, shouldn't it? Okay, so this is going to give you error. Okay, no solutions, no roots. Okay, if we put it equals 9, we should find that we have equal roots. So if we let k equal 9, what's going to happen? Yeah, we put that into our calculator. We should find that the root is 3, shouldn't we? That's going to give us equal roots. And then if we try 8, plus 8, we're going to get 2 roots. Okay, so this is showing us that for any value, this tells us that k has to be less than 9 in this specific equation so that we have 2 real solutions, okay? Okay, if you're feeling good, feeling really good, you need to do 5, 6, 7. If you don't finish it in the lesson, you finish it for homework. Okay, the most important thing is 5, 6, 7. If you're not feeling confident, do 2, 3, 4. But really, everyone should be feeling super confident. There are some challenge questions for house points, but you don't have to worry about them. And there is a further challenge for this whole chapter. Again, house points.